This video is to demonstrate how to graph transformations with points of accuracy. The first thing to do anytime you're giving a transform function is identify the parent function. In this case, the parent function is a quadratic. So I'm going to start with some very basic values. So I'm going to let x equal -2, -1, 0, 1, and 2. And because we're talking about the quadratic function, all we do is we take these values of x and square them. So that would be 4, 1, 0, 1, and 4. Now we start our transformations, and transformations have a specific order to them. The first transformation we want to look at is what's most inside our parentheses, what we call inside our function. In that case, I have a -3. A -3 means I'm going to shift to the right 3. So to shift to the right 3, that's a change in our x values. So what I'm going to do is I will take these values of x right here, and we're going to move them right 3, which means I will take my values of x and add 3 to them. So -2, when I add 3 to it, I get 1. When I take -1 and add 3, I get 2. When I take 0 and add 3, I get 3. When I take 1 and add 3, I get 4. 2 plus 3 gives me 5. My next transformation starts on the outside, and I look for multiplication before addition or subtraction. On the outside, I have this multiply by 2. This is a vertical stretch by a factor of 2. So I'm going to take my y values, and I'm going to do a vertical stretch. So vertical stretch of 2, which means I take my y values and I multiply them by 2. So I take 4 times 2 gives me 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. And 4 times 2 is 8. The last transformation on here is a +1 on the outside of the function. That takes me up 1. Up 1 again is another y transformation. So to go up 1, I will take this y times 2 column and add 1. So in green I have an 8. 8 plus 1 gives me 9. 2 plus 1 gives me 3. 0 plus 1 gives me 1. 2 plus 1 gives me 3. And 8 plus 1 gives me 9. Now, the transformed function then actually will have this column as its x values and this column as its y values. So the ordered pairs that I will be graphing for this transformed function up here will be 1, 9, 2, 3, 3, 1, 4, 3, and 5, 9. So let's go ahead and graph those. So 1, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 3, 1, 4, 3, and 5, 9. This is my transformed quadratic function. All right, let's try this again. This time I'm using an absolute value function, but I'm going to go with the same order as far as the transformation goes. Again, we're talking about absolute values, so if I talk about my parent function values, I'm going to let the values of x be -2, -1, 0, 1, and 2. Absolute value of each of these numbers means this becomes a +2, a +1, 0, +1, +2. Okay, now we work inside my function. Inside my function, I have a +1. That means I'm going to go to the left one. So I take my x values to move to the left one, and the way we move to the left by 1 is to subtract 1. So all my x values will be 1 less. So -2 minus 1, -1 minus 1, 0 minus 1, 1 minus 1, and 2 minus 1. Next, I will look on the outside, and I will start with what is being multiplied. In this case, I have a -3. That means the negative implies that we're doing a reflection over the x-axis, and a 3 is a stretch. When we're finding the value for that, we can do both those transformations at the same time. We're going to take all these y values, and we're going to do a flip, or reflection, and our vertical stretch all in one by taking our y values and multiplying by that -3. So 2 times -3 gives me -6. 1 times -3 is -3. 0 times -3, 1 times -3, and 2 times -3. All right, final transformation is a translation. This takes me down 2. Again, this affects the y values. So to go down 2, I'm going to take my y times my -3 column, there that's in green, and we're going to subtract 2. So -6 minus 2 is -8. -3 minus 2 is -5. 0 minus 2, -3 minus 2, -6 minus 2. My transform function then will have these set of ordered pairs, which means I will have the points -3, -8, -2, -5, -1, -2, 0, -5, and 1, -8. Let's go ahead and take a look at this. So -3, -8, 1, 2, 3, 4, 5, 6, 7, 8. -2, -5, 1, 2, 3, 4, 5. -1, -2, and then 0, -5, and 1, -8. This is my transformed function. And that's how we find points of accuracy on transformed functions.